Good morning, everyone. I am Dr. P. Balakrishna. We will be learning about digital electronics in this session. This session purely related to introduction for digital electronics. The concepts which are covered under this video is digital hardware. Under digital hardware, we will see what are standard chips, what are programmable logic devices, that is PLDs, custom chips, and design digital hardware. Let's get into the topics now. Digital hardware. The system which built with logic circuits, we call it as a digital hardware. Basically, logic circuits means the circuits which consist of AND gate, OR gate, XOR gate, NAND gate, NOR gates. So the circuits which build upon logic circuits using these gates, we call it as digital hardware. Now this digital circuits consist a basic element as a transistor. Transistor has emitter, base, collector, and there is a size which is having based upon a distance between emitter to base and base to collector. The size and its the number of count of transistors on a single chip was implemented by a law called as Moore's law. That Moore's law states that the number of transistors on a microchip doubles approximately every 2 years, leading to an exponential increase in computing power and decrease in relative cost. This law was given by Gordon Moore. That's the reason the law was named on his name as Moore's law. Next, the size of transistor. You can observe clearly that in the table that technology feature size, transistor per centimeter square, and number of transistors per chip. You can clearly see that the number of transistors per chip has gone drastically up year on year, and the size of the transistor is also coming down year on year. As in the size of the transistor is coming down, the number of transistors that are accumulated or accommodated on a single chip is also getting increased. As you can see in the year 2016, 78 nanometer was the size of the transistor, where 2.430 million number of transistors were accommodated onto a single chip. While coming to 2012, the size of the transistor is came to 36 nanometer, where 9718 million number of transistors got accommodated onto a single chip. So this is how the size of the transistor is getting decreased and accommodation of more number of transistors onto a single chip is getting increased. Now when we are telling that we are preparing an integrated circuit using these transistors, these chips has to be placed onto one board. That board we call it as printed circuit board. You can see on the line PCB. So the PCB contains all these kind of chips which are imprinted onto it. Some of the examples of PCBs: to perform arithmetic operations, we will be using microprocessors. To store data, we will be using memory chips. To interface connections from input to output devices, we will be using interface chips. So these are some of the examples of integrated circuits, or ICs we call. Next, we will be having some existing chips which are implemented. They are standard chips, programmable logic devices, custom chips. Now standard chips. Now what exactly standard chips are? Like numerous chips are available that realizes some commonly used logics. These chips are referred as standard chips. And a designer chooses to interconnect such chips to realize large logic circuits. Like a drawback of these standard chips is inefficient use of valuable space on PCBs and fixed non-programmable functionality. Means you cannot program these chips here. Now coming to programmable logic devices, these chips are programmable devices. Now means the user can program his own condition. With his own conditions, he can put that program onto the chip and implement the required output. The PLDs are widely used today and could be one-time or multiple-time programs, such as electrically erasable chips which are available in the market currently, or also we can call it as in-system programmable devices. Now there are fixed programmable gate array or field programmable gate array, that is FPGAs, which are predominantly called as PLDs. Those are advanced PLDs with a large number of programmable logic elements and switches which are present in it. So using FPGA you can program more number of logics onto a single IC. So this is a field programmable grid array where you can see a group of logic cells and a memory block and interconnection wires. Now apart from FPGA we have custom chips also. Custom chips also called as ASICs, that is application specific integrated circuits, where a single application can be incorporated into an IC. Using this IC I can make any kind of function to work. For example, if I am having a refrigerator or a microwave oven or air conditioner, each device have its own specific functionality. So that functionality can be incorporated into one single chip. That single chip can be utilized for that one purpose. So those kind of chips we call it as custom chips. And these chips are also called as programmable logic devices. So this is what about related to custom chips. Now once chips are done, like the design of those chips has to be made through one flow model. Like the design process includes, we need to understand what is the required product, means what kind of product we are looking for. After knowing what kind of product, we need to define its specifications. Once after specifying the specifications, we need comes under initial design. We need to come under initial design. Once a initial design has been done, when we have written the program in the any kind of simulator, then we need to simulate it. Simulation means we are going to check the design, whether the design which we have designed is working properly or not. The proper definition for simulation is creating a model and representation of a system where phenomena to analyze its behavior under various conditions. It allows researchers, engineers and scientists to test hypotheses, visualize complex scenarios, predict outcomes without the need for real world experimentation. Now there are two types of simulations, like physical simulations will be there and computer simulations. Like in computer simulations there will be some tools where we are going to use those tools to analyze our design. Now after simulation we are going to check whether our design is working properly or not. If my design is not working properly, then I will go back to redesign, again I simulate and I come back to design correction, uh, design verification. Now if it is working properly, then I will send that a design to prototype implementation, means I am going to implement my design onto an hardware. Once onto hardware, when I'm putting the code onto hardware, and when the IC or integrated chip is getting manufactured, after manufacturing I'm going to test it. If it is meeting my specifications, I will close that product. If it is not meeting its specifications, then I will go for minor errors or corrections, which I'm going to correct it and again get back to my prototype implementation and testing. This is how the design process goes with a digital hardware. Coming to specification, like the specification, like how the process begins for a product, means what are the needs that is looking after for the manufacturing of the product. Initial design means we are going to set up some general structure for initial design. Using that we are going to tell what kind of initial requirements for the design is needed. Simulation, you already know that we are using that design to test the design for various or numerous inputs. Like CAD means computer aided design, which are used for testing these kind of designs. Coming to digital hardware design. Now coming to digital hardware design, there is a basic design loop where a design concept is taken. With that design concept we are going to tell with the initial design. We will take an initial design. Through initial design we are going to simulate it. If it is working properly, it is a successful design. If it is not a successful, then again we are going to redesign it and simulate it. So this is a basic design loop for our digital hardware. Coming to design of hardware unit. Now the previous thing was for only programming kind of thing. Now this is for hardware unit. Once a design on computer or by while writing the program, if it is successful, then we are going to get on to the second step, that is design of digital hardware unit, where actual integrated circuit will come into the picture, where we are going to manufacture that physical hardware which is going to come out of our design. Now this digital hardware product usually involves one or more PCBs. PCB stands for printed circuit boards that contain many chips and other components. Now in the figure also you can see this the rectangular shape, whatever we call it as PCB or motherboard sometime. On that board we are going to have small ICs. Each IC will be having specific tasks to perform on the motherboard. So this is how if there is a one sub chip which is present in our motherboard, that chip contains these kind of logic gates, like you can see AND gates, XOR gates, NAND gates. So these kind of gates are will be there. Now these gates are in turn, these are the gates means these are the symbols which are assigned for transistors. Now you can see here the transistor circuit here, transistor containing three terminals, that is base, emitter and collector. So these are the things of basic elements which are present on a integrated circuit or printed circuit board. So this is how the process goes. You can see the design flow. Once hardware is prepared, like design concepts we will take, we will partition the design into one block or two blocks. Based upon that, we will check the interconnections between input and output and check the functionality. Whether if it is working properly, then we will go for physical mapping, and timing of simulation also is checked at that point. If it is working properly, then we will implement it. If it is not working properly, we will go back to the initial partitions. So this is how the process flows under digital hardware design. So these are some of the points which are discussed under this topic. We'll close this session here and we'll continue with the next topic in the next session. Thank you.